Hello, this is Mr. Craig, and this is the answers to the homework from day 4. And I've kind of made this video a little bit smaller so that I don't give away the answer as easily. So let's look at question number 1. And I believe that the question asks for binary compounds or molecular compounds here so that we know that we're looking at nonmetals with nonmetals. Now, one thing that's really neat about that is that we get to use Greek prefixes, which means that, hey, we don't care about the charges on these. So since we have 4 sulfurs and 2 nitrogens, the sulfur keeps its name, sulfur. The nitrogen, we drop the last syllable and add IDE. So since we have a 4, we have tetrasulfur dinitride. And if you wish to hyphenate it, you may do that. So tetrasulfur dinitride. All right, looking at letter B. We have B, which is boron, and we only have one of those, so we don't need a Greek prefix. Yes, mono does represent 1, but never ever use mono on the first element. And then we have 3 iodines, but since we have 2 nonmetals and we have iodine, we're going to drop the INE and add IDE, so we have iodide. Yet we have 3 iodines, so that means that we have boron, triiodide. Boron, triiodide. And again, hyphenating is quite alright if that's what you like to do. Letter C, we have P2O5, which means we have phosphorus and oxygen. Drop the last syllable on the, or last 2 syllables on the oxygen, so oxygen. The egen goes to ide, so we have oxide. Since we have 5 of those, it's pentaoxide. Phosphorus, since we have 2 of those, we're going to call that diphosphorus pentaoxide. Diphosphorus pentaoxide. Okay. Letter D. Antimony tribromide. So again, antimony, probably one real easy way to remember the symbol for antimony is that it rhymes with alimony. And if you have to pay alimony, you have to pay that son of a... So there you go. SB is the symbol for antimony. Again, we don't care about what the charge is. And tribromide, the tri means that we have a nonmetal to nonmetal, so the antimony is acting like a nonmetal in this case, but which means that we have 3 bromines, so it should be SbBr3. Okay, so SbBr3. Diphosphorus tetraoxide. Okay, so we do have a di here, and we have a tetra. Actually, so when we have di, that means we have 2 of those. So P2 is our diphosphorus, and tetraoxide, so we have oxygen again, and tetra means that we have a 4. So P2O4. Good. Okay, again, don't care about charges, so don't get enamored by that notion there. Tetranitrogen dioxide, so again we have tetra at the beginning of the nitrogen and di in front of the oxide. So that means we have 4 nitrogens and only 2 oxygens. So N4O2. Okay, N4O2. Alright, now looks like we have ionic compounds here. So the barium fluoride, now we do care about charges. So when we write these out, okay, move it over a little bit. The barium, probably a good idea to write the charges above. Barium is in group 2A, and you can look on your periodic table here. Barium has a +2 charge, where fluorine has a -1, so that means that we're going to need 2 fluorines for every barium. So we should have barium, BaF2. Okay. Looking at calcium nitride, same thing, where we have a +2 charge for our calcium. The nitrogen has a -3. We have a metal to non-metal, so we have an ionic compound. So to get the algebraic sums to equal 0, multiply them by each of that. Now, one thing that somebody taught me a while back is that whatever the subscript or whatever the charge is, like for the fluorine, it has a charge of -1. That means that'll be the other thing's subscript. The barium has a +2. That means that's the charge of that. Now, that works for a lot of the compounds, but do remember that we always look for the smallest whole number ratio for our subscripts here. So if you had a 4 and a 2, reduce that down to a 2 and a 1. But for the most part, it works out very, very well. So if you have calcium with a +2 charge and the nitrogen with a -3 charge, since calcium has a +2, we need 2 nitrogens. And look at that, we do. Since nitrogen has a -3, we need 3 calciums, and we do. So calcium nitride. Pretty cool. Aluminum oxide. Again, aluminum has a +3 charge from our aluminum slide. Oxygen has a -2 charge. Very, very similar to the problem up above. Aluminum with the +3 and the oxygen with the -2. Since the aluminum has a +3 charge, we're going to make sure that we need 3 of those and 2 of those. And there's your aluminum oxide. Pretty neat. All right. Lithium has a +1 charge, so it's already balanced as written. So we can call the lithium lithium and oxygen lithium oxide. And there it is. Now again, we don't care about the 2 here. Again, we have an ionic compound. So the reason why we have a 2, just like what we had the 2s and the 3s up here, so we could balance out the charges. Lithium has a +1 charge, oxygen -2. Okay. All right. Silver. Again, remember silver has a +1 charge, and the iodine has a -1, so it's a 1-to-1 ratio, which is very, very nice. So we just call this silver iodide. And again, no Greeks and no Roman numerals. Again, silver only has a single charge, which is +1. All right, F. Oh, sorry, I did not mean to do that. Okay, F. We have Na and F, and Na has a +1 charge, sodium a -1 charge. That's why we have 1 and 1. So Na is sodium, F is fluorine. Drop the I and E and add ide, fluoride. And sodium fluoride is your toothpaste. Okay, that's the active ingredient in your toothpaste, which is your source of fluorine, or fluoride, sorry. All right, here it looks like we might have some polyatomics here. So Mg, magnesium sulfate, so +2, -2, those are balanced already. And again, no Greeks, since we have metal with a non-metal, so magnesium sulfate. Okay. Na2SO2, we have 2 less oxygens, so that means that we have a hypo ite, so sulfite. So hyposulfite, so we have sodium hyposulfite. And again, don't worry about your charges, or I mean how many we have. Okay, the charges are there to balance the equation out. So sodium hyposulfate, and again, that is not a Greek prefix, so don't freak out and go, oh, that's a prefix. Yeah, it's a prefix, but it's not a Greek prefix. Okay. All right. Again, here we have a bunch of non-metals, but we do have an ionic compound, because once we recognize who our metal is, in this case here, NH4 is ammonium, where ClO3 is one of your polys, ammonium chlorate. Okay, ammonium chlorate. And that has a +1, -1 charge. All right. Now the parentheses do a pretty nice job of identifying who the poly is. So use your parentheses to help you name this. Magnesium, Mg, and then C2H3O2, what is the name of that poly? That's right, it's acetate. So magnesium acetate here. Okay, pretty cool. All right. Again, we have our NH4 in front of us. The IO3, so ammonium iodate. Ammonium iodate. Okay. Ag. What is Ag? That is, remember, there is no G in gold, so that has to be our silver. So silver nitrate. And again, these both have a 1 charge, either +1 or -1. So silver nitrate. Magnesium hydroxide. Okay, now we have the names. We're going to the formulas. Okay, so magnesium hydroxide. So we have our magnesium with a +2 charge. So magnesium +2. Hydroxide, -1. Now here's a problem that a lot of students do. They go, oh, I need 2 hydroxides. So they just stick a 2 there and they walk away. Well, what have you done if you just stick a 2 there without putting parentheses? Well, if you don't put parentheses there, that means that we still have 1 oxygen and 2 hydrogens. We don't have 2 hydroxides. We only have, well, I don't know what we have, but to get 2 hydroxides, you have to put the 2 or put the parentheses around the polyatomic and then indicate how many we need. Okay. Potassium phosphate, again, potassium is K and has a +1 charge. Phosphate, one of your 10 polys, which is PO4 with a -3. So since we have phosphate as our highest value here, we don't need to put parentheses around it. Well, we don't need it because we don't need it. Phosphate, we need 3 of those to balance out the charges, so K3PO4. Calcium nitrate, calcium Ca with a +2 charge, nitrate NO3 with a -1 charge. So to balance these out, we need 2 of those, so put parentheses around the poly. There's your calcium nitrate. Barium hydroxide, very similar to a problem earlier on, where we have barium with a +2 charge, hydroxide with a -1, so that means we need 2 of those. So barium hydroxide. Sodium sulfite, the ITE ending there means that we've taken an oxygen away from this polyatomic. So sodium with a +1 charge. Sulfite means that we have sulfate with 1 less oxygen, so sulfite is SO3, and it has a -2 charge. So that means we need 2 sodiums. So Na subscript 2 SO3. Per. Nice. Okay. Potassium, still going to be a +1 charge. Perchromate, so chromate has a -2 charge, and it's CrO4. So we need to make this CrO5, and it has a -2, so that means we need 2 of those. Okay. Make sure you know your 10 polys. Lithium sulfate, so lithium is Li, with a +1. Sulfate, SO4, with a -2. We need 2 of those. So Li2SO4. Okay, now we have metals that have more than 1 charge. Now, how do we know that it has more than 1 charge? I think I said, yeah, ionic compounds 2. Now I'll be more specific on the test on that. These have more than 1 charge. Okay, so knowing that it has more than 1 charge, we have to show Roman numerals to indicate the charge for our metal. So since I know that iron has a +2 charge, because sulfur has a -2, that means that my iron will be iron Roman numeral 2 sulfide. Okay. Iron Roman numeral 2 sulfide. That's a little cleaner version of what I just tried to write. Okay. Cobalt, again, one of those metals that has more than 1 charge, but I'm going to use my non-metal to tell me what the charge on my metal is. So carbonate, it has a -2 charge, and there's only 1 carbonate. How do I know that? Because there's no parentheses. Very good. So I don't have a subscript on my cobalt, so what must the charge on the cobalt be? That's right, +2. So this will be cobalt Roman numeral 2 carbonate. Cobalt Roman numeral 2 carbonate. Okay. Again, copper can have multiple charges. Sulfate has a -2 charge. Since I only have 1 copper here, that means it has to have a +2 charge. So this means that I have copper Roman numeral 2 sulfate. Again, the -2 means that I have a +2 charge. Alright, SN. Remember, it's a sin to 10. Again, these are statements that my students have given me, so I apologize for that. We do know that tin has more than one potential charge, so the bromine, which has a -1 charge, and there's 4 of those, and since there's only one tin, that means it has to have a +4 charge. So this is tin, Tin, Roman numeral 4, bromide. Okay, again, the 4 indicates the charge on my tin, or for each metal atom. All right. Mercury, I don't have a catchy thing for that. Iodate, IO3 with a -1 charge, but there happens to be 2 of those, so that means we have a total charge of -2, but there's only one mercury. So we have mercury, Roman numeral 2, iodate. Okay, mercury, Roman 2, iodate. PBS. Sulfur, -2, lead, +2. So lead, Lead, Roman numeral 2, sulfide. Good. Manganese has a lot of charges. Man, I think it has about 4 or 5 charges. I can't remember right off the top of my head. But you don't need to memorize all those charges, but do know what the charge is if you have a nonmetal that, say, has a -2 charge and you have 2 of those. So the manganese has to have a +4 charge. So manganese, Roman numeral 4, oxide. Okay. Or if you're calling O2 peroxide, which is viable, then that means that the O2, the MnO2, would simply have a -2 charge total. So it would be manganese, Roman numeral 2, peroxide. So that's an option as well. Now, we don't talk too much about peroxides in here, but it is possible. So if some of you came up with peroxide, good job. All right. AuNO3, again, make sure you know the difference between silver and gold. Nitrate has a -1 charge. We have 3 of those. Gold, in this case, has a +3 charge. So gold, Roman numeral 3, nitrate. Good. Again, we have tin, and we have hydroxide here, which has a -1 charge with 4 of those. So that means that the tin has a +4 charge. Tin, Roman numeral 4, hydroxide. Okay. Tungsten, or wolfram, if you're German. In this case, it is W, and since it has a 3 there, that means it has a +3 charge. Oxygen, or oxide, has a -2 charge. So we need 3 of those for every 2 of those. So W2O3. Nickel 3 sulfite. Sulfite, keep your eyes open on that. Nickel doesn't change. Ni with a +3 charge. Sulfite means that we have sulfate with 1 less oxygen. So SO3 with a -2 charge. You need 3 of those and 2 of those. So 2 parentheses 3. Again, polys parentheses. Okay. So I do have those if you want to check those online as well. Mercury 1 sulfide. Now sulfide means that we're looking at an element here. Mercury, in this case, has a +1 charge. Sulfide is sulfur, but it has a -2 charge, so that means we need 2 of those mercuries. Okay, so Hg2S. Copper 2 phosphate. Again, copper can either be a +1 or +2. In this case, it's a +2 because of the Roman numeral. Phosphate, PO4, a -3 charge. So I need 2 of those and 3 of those. So 3 parentheses 2. So Cu3 parentheses PO4 2. Okay. Bismuth, Bi. Roman numeral 3, so that means it's a +3 charge. Iodate, IO3 with a -1, so that means we need 3 of those. Okay, so Bi parentheses IO3, 3. Okay, again, recall that 3 does not mean that we have 3 iodates. That means that we're looking at iodate. Lead 2 chromate, so lead PB, and chromate CrO4, and the chromate has a -2 charge. Come on, pen. Lead's +2. Good to go as written, so we don't need to change anything. PbCrO4. Okay. Copper Roman numeral 1 iodide. So copper can either be +1 or +2. In this case, it's a +1. Iodine also has a -1, so CuI. Okay. Acids. Here we go. Nitric acid, again, no hydro here. So nitric, if it ends in ic, we're looking at a poly with an ATE ending. So HNO3. So nitric. HNO3. Good. Hydrofluoric. Again, the hydro indicates that we have no oxygen. So the fluoric means that we have just fluorine. And hydrogen means that we're looking at an acid. Hydrogens at the front mean that you're looking at an acid. Hydrogens at the back means you're looking at a base. What if it has a hydrogen on the front and back? Ooh, we'll talk about that later. All right, hydrobromic. Again, recognizing that we have hydro. So bromine, and it has a -1 charge. Sorry, the nitrogen, or the fluorine had a -1 up there. So we need 1 hydrogen. So HBr. Okay. Chloric acid. Since we have the ic, that means we're looking at a poly. So chlorate, ClO3, and since it has a -1 charge, that means we need 1 hydrogen. HClO3. Ching. Acetic acid. Well, make sure you know your polyatomic for acetate because we have the ic ending. So acetate is C2H3O2, and that all has a -1 charge. So that means we have HC2H3O2, which is that. My pen isn't working very well. Carbonic acid. So that means that we have carbonate, which is CO3, has a -2 charge, so each hydrogen has a +1. We need 2 of those. So H2CO3. Okay. Hydrochloric acid, no oxygens. So chloric is chlorine, and then put a hydrogen in front. So HCl. Alright, now we get to name these. Alright, since we have no oxygen, this is hydro, drop the nitrogen, ogen, and put ic. So you have nitric, hydronitric acid. Okay. Again, if it ends in IDE, we change it to ic. If it ends in ATE, we drop it and add ic. Again, no oxygen, but we do have phosphorus, so phosphoric, hydrophosphoric acid. Okay. Here we do have a poly, so no hydro. We have sulfate, so drop the ATE ending and put ic, so we have sulfuric acid. Nothing really exciting about that. Here we just wrote this one out earlier. We have no oxygen, but we have chlorine, so get rid of the INE and make it ic. So chloric, hydrochloric acid. Okay. Looking at this one, don't be distracted by the 2 because all of these acids are ionic, so we don't use Greek prefixes for any of these. But there is no oxygen, and we do have sulfur. So we have hydrosulfuric acid. Okay. Here we do have a polyatomic, phosphate. So get rid of the ATE ending and make it ic, so phosphoric acid. No hydro, it's just phosphoric acid. HI, again, no oxygen, so hydro. And the iodine is iotic, if you want to call it that. It's probably so hydroiodic acid. And again, if you called this hydro, I don't know how you could say it any other way, but if you came up with some crazy way to pronounce it, I think I'd accept that. That'd be okay. Oh, hey, that's the end. All right. I hope this video has helped on naming these compounds, and we really need to be very, very efficient in naming compounds. So I hope this video has helped, and again, if you have any questions or you need more practice, I have a ton of practice that you can look at. Actually, if you go to the calendar and take a look at the day's date, at the bottom of today's date, or the date that day 4 on the lecture notes, I have more practice on there, and I have a ton of practice problems. Let me see if I can actually pull one up here. I know that I have a limited space here on this. So Ionic chemistry, yeah. On the day 4 lecture notes here, where it says practice test for naming formulas, acids, click on that, and again, this hasn't been updated yet, but click on that and that'll take you to the website that looks like this. And if you take a look at these guys down here, okay, this will give you more practice on naming compounds. And I apologize because when I made this video, I made it for a region, and I know you're only getting a certain amount of that region. But as always, I hope this video has helped. And if you do have any questions, definitely go and look at these or give me an email.